I'm going to show you how to change the battery on the Isolo CloudVocal microphone transmitter. I first bought this in August 2022, and although I really like the product, my experience with it hasn't been great. There's a number of people reporting issues with the battery, either the battery or the power switch, and actually they're both connected to a battery problem. And what's happened, I believe, is that the early batches of this microphone transmitter, the battery used is not a great quality, and what's happening is that during charging the battery is swelling, and that's doing two things. One is that the battery charge the retention period is diminished. They're advertised as having 5 hours retention initially, dropping to 80% of that, so 4 hours after 300 charge cycles. This is now my third one, which has been replaced under warranty. And each of them, after only about 15-20 charge cycles, the battery retention has dropped to 1 or 2 hours only. Really bad performance. The second thing that happens, and I've had this as well, is that the power switch seems to seize up. It doesn't seem to work. The plunger isn't tactile anymore. And that again is because the battery inside is swelling and putting pressure onto the micro switch. We'll have a look at that in a moment. So both of those point to a bad battery. I really like the product. I want to know I can rely on it. So I want to know that in the future I can still use it. I don't like the idea that I have to keep sending them back to the manufacturer to have the battery changed. So I'm going to do it myself, so let's have a look how to do that. So the first thing you're going to need is a T4 Torx screwdriver, and there's 4 screws that need to be removed, 2 on each of the side panels there. So let's do that. Okay, so that's the 4 screws removed. The next thing we're going to do is to remove the panel, this panel where the power switch is. It should just pull off. You may have to prise it off slightly because this connector, the USB connector, is kind of pinching the panel down the bottom, so it just needs a gentle tug to loosen that. There we go. And then very gently remove that. There we go. And so now we can see inside. You can see there's the battery along the top there, and you can already see it's kind of deformed. It's kind of bowing a little bit. Here's the power switch, and you can see the proximity of the battery to the power switch. So what we're going to do now is remove the PCB out of the casing, and actually it's quite easy. It just slides, so we're going to grab this and gently push at the PCB here, and it will slide out of the casing. Before you do, there is a connector, antenna connector, micro coaxial connector, which let's have a look, see if we can see it. I think you can see it there. You can see the antenna there terminated on this connector, so that needs to be prized upwards from the board connector. So you need something to do that, but what you need to do is to use non-conductive tweezers, because the battery's still connected. If you use metal tweezers, you're going to short something out. The other thing I should say is actually before you do this, it's a good idea to discharge the battery fully anyway. So that's what I've done. I've just left this microphone transmitter on until the batteries run out. So now let's just gently prise off the coax connector here. There we go. Here it comes. There we are. There it is. Let's hold that up there. Just pull that out slightly. The casing is earthed, so again you've got to be careful it doesn't touch other components as you disconnect it. So now we've disconnected the antenna. The PCB itself is free to slide out. So let's gently do that. Okay, so I'm going to put this plastic onto the PCB and push, and at the same time kind of try and pull from this end. There we go. Gently pull that out. Okay, so there's the casing and here's the PCB. So there's the battery, there's the micro switch. You can see how close it is to it. In fact, the casing is touching the micro switch, so you can see that if that does deform or swell, puts pressure onto that micro switch, and that's what's causing the power switch problem. So what we're going to do is take this battery off. First thing is to disconnect the connector from the PCB connector. It's a good idea to just make sure you observe the polarity there, that the positive pin is on the left hand side there. So I'm going to now, with tweezers, I'm going to attempt to pull this connector out. Again, using plastic ones. There we go. So there's the battery connector out, and then the battery is held down by some form of adhesive onto the PCB. So we just need to kind of prise that out. But before we do that, it's a good idea to gently apply heat to the bottom of the PCB. To loosen the adhesive a little bit. So I'm now just going to pop away and do that, and I'll come back and then remove the battery. Okay, so I've applied some heat. The battery is quite warm. Don't overheat it though. These are lithium polymer batteries which are quite volatile. You've got to be very careful. So with a flat edge here, it is metallic, but the battery's disconnected now. I'm going to gently start prising up. There we go, it comes. You can't apply too much force because you might damage the PCB. Here we go, you can hear the adhesive giving away there. So now I'm going to just see if I can use my fingers for the rest. There we go. Okay, that's the battery removed. So the battery type, lithium polymer battery, it's 501838. That's the battery type, and actually they're the dimensions. 50 means it's 5 millimeters height. 18 is 18 millimeter width, and 38 is the depth, the length of the battery. So now to replace that battery, you need to get another part like this and just reverse what I've done. The part may or may not come with this connector. If it does, great, just observe the polarity, make sure they're the same. If not, you can remove this end connector. I'll show you how to do that in a moment, and fit it onto the new battery. I'm not going to use the same battery. Two reasons. One is that I can't get one. They're not easily available, this type. You can buy them if you buy a big batch of them, or if you're lucky enough to find a supplier that does them. I can't. So I could use a smaller battery on this footprint here. You can't use a bigger one and hold it within the case. But the smaller one is reducing the charge retention anyway, which is, I don't really want to do that. I'm going to use a bigger one, and I'm going to secure it on the outside of the casing. That way I can see it and I can change it easily in the future. So I'm not going to use this. So if you want to, and if you can find the same battery, apply some adhesive, maybe double-sided sticky tape, stick it down, plug it back in and assemble it, and you're away. So I'm going to do a different method, which I'll talk about now. So here's the original battery, and this is the battery that I'm replacing it with. It's only slightly bigger, but it's deeper, so it won't fit inside the case. I've got the manufacturer of this one, lighter energy, which I think I'm hoping perform better. So the capacity is 600 milliampere hours compared to 320 of the original, so it's almost double. So in theory, on a full charge from new, the thing will run for maybe up to 10 hours, 9 or 10 hours. I don't need that, of course, but what I'm looking for is I still want 2 or 3 hours out of it after the battery's degraded performance. So even if the charge retention of this new one drops to 40% of new, then that's still 3 or 4 hours. So that gives me confidence that I'll be able to use this microphone transmitter for quite some time before I need to replace this battery. Now, because it's bigger, I can't fit it inside, so I'm going to fit it outside the case. So what I'm going to do is I'm going to mount it on top here, and I'm going to drill a small hole in the case and drop the wires through, and then connect it. So it won't look as pretty, but it'll do the job, and that's what I'm after. It doesn't add any extra weight. This battery is only marginally heavier than the original, so there's no noticeable difference. The only other thing to say is, as I mentioned before, these lithium polymer batteries are quite volatile. If you pierce the casing, then they can cause a fire. So you've got to protect them. So I was looking for a neat little box to fit on top, and I could put that in. I couldn't find one. If you've got a 3D printer, there's a great thing you can do there. Print yourself a little box to fit on top. I found this plastic sleeving, which is rigid plastic, and this fits nicely inside it. So I'm just going to stick this on the outside like that. So this is how it's going to look, and then we'll test it out and see how it performs. Okay, so I've drilled a hole for the battery wires to go through the casing, deburred it. So the plan is, here's my new battery. I'm going to feed the wires through the hole there, bring them out here so that I can work on the wires. I'm going to take this connector off the old battery so that I can reuse it. I've got I've got the mini crimps that fit into this connector, so I'll crimp the ends of the wire of the new battery, feed them into the connector. Of course, I have to have fed these wires through this hole before I can do that, because otherwise I wouldn't be able to fit that connector through the hole. And then once that connector is fitted, I can then fit the connector into the board connector here, so there'll be a long length of wire. Then I'll slide that back in. I'll fold that wire back on itself as it feeds in, and since I've removed the battery, there's plenty of room for this surplus wire to kind of coil up here, and then screw it all back together and see if it works. Just a word on working with the new battery. I've already mentioned how volatile it is. When you buy a new battery, they'd normally insulate at least one end so the wires aren't connecting. So when I'm doing this work, I just got to be really careful that I don't short these two wires together. The battery won't like that very much at all. Okay, so I'll do that and come back. On the screen here, I've got a magnification of that tiny connector, just to show you how to remove the wires so you can reuse the connector. Each of these wires is terminated on a crimp, which is housed in this connector, and you slide the wire in, and this little tab, which is kind of sprung, if you like, it kind of springs out here, so that you can't retract the wire. If you try and pull the wire, that little tab is going to hit the housing here. So that's how the crimps work. So to remove a wire, what you need is something very, very small, like a pin, pressed on this tab here. You need to push that in, and at the same time pull the wire out, and the crimp will slide out. I'm going to do that now. I won't be able to film it as I do it because I need both hands. So here's the battery now, the old battery with the wires and crimps removed from the housing. That's the housing that I'm going to reuse. You'll notice that I've put a red mark on the housing for the red wire, and equally on the PCB connector, just to make sure that I don't get wires mixed up, because that's probably going to damage the circuit if you get the polarity mixed up. So now to fit it to the new battery. Okay, so I fitted the new battery, as I said, by poking wires through the hole in the casing, terminate them on the connector. I've got the polarity right, red and black polarity. So now I'm starting to assemble it back together. So first job, I'll get this the right way, is to connect the new battery onto the PCB connector. It's very fiddly, so let's do this. There we go. Okay, so the first test now is to see if this thing powers up. There'll be residual charge in there from the supplier, so I'm going to press the power button, and I've got the power LED on and solid on, which means it's already hooked up to the receiver, which is good news. And I haven't even got the antenna connected. The receiver is just down by my side, it's fairly close, so that's good. So now I'm going to turn that off again, and then assemble So what I've got to do is carefully loop this power cable around. And then begin to slide the PCB back into the guides. Right, so I just want to grab the battery cables and pull them through a bit more actually, like that. Make sure I can feed in the surplus through. There we go, so the PCB is now on both sides in the card guides, and now I'm just going to gently push it in. There we go, just have a look at the other side, see what's happening. Yep, you can see the battery wires just in the back there are nicely tucked away. So just gently push that back. Just gently put that there for a moment. So the PCB is now back in its place. What I'm going to do is, at this point, I'm going to put the screws in the side panel here. Okay. And now the last thing to do is to pop the coaxial connector here onto the connector on the PCB. So I'm going to try and do it whilst looking around the camera because it's in the way, so it's a bit tricky. Let's have a go. Okay, so that was quite fiddly. I was struggling trying to do it looking through the camera, but there you can see it's now fitted to the PCB connector. Everything's in place. You can also see probably the space around that connector now and the power switch because the internal battery's gone, which is good. And now just to fit the end panel again. Okay, so it's assembled now. Just going to test it one more time. Look at the LED, make sure it's powering on and connecting. There you go, I don't know if you can see it through there. Powered on and hooked up to the receiver, so all is working well. So all that's left now is to fit this sleeve onto the top to protect the battery. I'm going to use double-sided sticky tape to do that. Just turn that off again. So here's the finished product. Sleeve has been attached to the case through with double-sided sticky tape. Batteries inserted inside. You can see kind of bubbly stuff there. I've put some clear silicone in there just to hold the battery firm, stop it moving. And that's it. The wires are visible, but they're protected. They're not exposed as such. And that's it. Plenty of air around the battery for when it's charging. And it works. Turn it on. There we go. Hooked up to the receiver. So now I'm going to charge it and just see how long it takes to discharge. And I'll be back. So I charged the microphone with the new battery and tested it, and it lasted about 8 hours before it ran out of charge, which is pretty good. It's not quite as much as I originally thought by just comparing the capacity, 600 milliamps of this battery and the 320 of the one before. I was expecting about 9 hours, but 8 hours is pretty good going. I'm still quite happy with that. Just a reminder that I'm not needing 8 hours straight performance from the mic. What I'm looking to do is to provide plenty of headroom so that if the battery degrades, I can still use it for a gig. So I'm looking for a minimum of about 3 hours charge on the microphone for a gig, which means that this battery can lose up to about 60% of its capacity and I'll still have 3 hours, and that's what I'm looking for. So yeah, I'm quite happy with it. So just some closing remarks. If you have a battery or a switch problem, check whether your mic is under warranty. Check the status, because if it is, CloudVocal will change it. They've been pretty good when I've approached them, and I've seen from others that they seem to be very responsive. And also they do claim to have solved the battery problem. I'm guessing that they've got another supplier. I'm yet to be convinced of that, which is why I've gone this route. So yeah, it's not pretty what I've done, but it's effective. I think an improvement would be, as I've mentioned before, to get a 3D printed black box on that, and then that would look quite good. And I think the other thing I might consider in the future is to put an inline connector outside of the casing here somewhere, so that if I want to change the battery, I don't even need to open up the unit. I can just unplug it from the outside and plug in a new one. That's it. I hope you found it interesting and useful. Happy to hear your comments. Good luck.